Hello everyone, this is a Leetcode video to sum solved in Ruby. I'm going to explain the problem first and tell you how to solve it. And then at that point, you can pause the video and try to solve it yourself. Or you can stay and look at my code. So basically, it says, given an array of integers, nums, and integer target, return the indices of two numbers such that they would add up to target. So you're going to get an array of numbers. Let's just say it's 1, 3, 5, 9. I should make it have an answer, so I'll put 8. And the target will be, let's say, 8. So you'll get these two numbers. Nums, the array is right there. Target is right there. And what you're going to have to do is check every number in the array until two of them add up to the target number. Yeah, that's right. So here's the actual test case. And then once you do that, you can return the indices. 0, 1, 2, 3, 4. So in this case, the answer is 1 and 2 because 3 plus 5 equals 8. So, hope that made sense. If not, you can watch it again. But what you're going to have to do, now that you have to loop through it basically. So that's all the explaining that I'm going to do, because it's pretty simple. I'm going to show my code now. So now is the time to stop watching if you want to try to code it yourself. And then I'm going to go into the time complexity, and then I'm going to show other people's solutions and why my solution, I believe, is a little better. So here is the Leetcode problem. I have a number of solutions here. I solved it in Ruby and Python. I've also solved it in JavaScript on a separate account. Let's start with this one. So this one beats 71% of the people in runtime, but only 14% in memory. It's probably because of the hash map. If a lot of people solve it via double loop, if you loop and then loop, so you check every number and then check every number inside of it, that would be less memory, I think, because you don't need to save anything to memory. The hash map, you have to save the actual number to memory. So you have both the array of numbers and a hash map. And I think that most people probably solve it like that, so that's probably why it's like that. But this is actually an efficient solution, because basically what I'm doing is I have a hash map, I create it with a hash.new, and it's actually, let me get the coloring real quick. So I'm going to copy this and just go back to description and just stick it here. So we have the coloring. You create a hash map and you initialize every blank number to -1. And then you go through, this is basically just a for loop. It's the array, if you're not familiar with Ruby, and the array with the index, and then you just get the number in the index each for loop. But this is the important part. You have to check what the difference is between the target and the current number. So that would be I, if in some cases, or number, or num. And then you calculate that, and then you just check if it's already in the array by true target equals not equal -1. Then if it is, you return the index of the target number and the index of the current number. The current number is right here. So And then after you loop through it and check, you have to add it to the hash map. So then next time it will be checked. So in for loops in the future, it'll be checked basically, and it will show up, and that'll be the answer. So let's just submit this. This beats 53% of all people with Ruby, and only 6.5% people with memory. I explained why that isn't the case previously. Let's check out a different, my improved version. So I'm just gonna get the coloring again. This is the approved version, a little more efficient. Instead of looking up in the hash map, it uses the .include question mark, which is a little bit more efficient. And that's basically it. You can also, I could actually skip the -1, make that even a little more efficient. Now I have to initialize that. That's like an O of 1 reduction, I think. Submit this and see what we get. Previously got about 86. Oh, I just copied it wrong. I copied the solution wrong. Didn't get the last end. So this is a little more efficient. It's about 78% of people. This one got incorrect because there's an end here when it started, but there's no end for def. Basically, I just copied it wrong. And this is actually on the high. I can't even tell where I am. I guess this is... I can't even tell what these are. The graphs are. I guess I'm somewhere... I guess I'm right there. But I don't know. I'm here. It's a very small range. But it's not a big drawback. 212 versus the best solution, 210, is almost nothing. Now we're going to do the O of N. So, basically with my solution, you only have to do one for loop. Everything like this right here and these right here is O of 1. So that doesn't really matter much. And this is O of 1. But this is a loop. So my solution is actually O of N. Because it grows with the size. And I believe that's an efficient solution because looking at some of these people, let's just look. Ruby. This one's O of N, but it might be more. Yeah, this one is worse. This one is worse. Might be a little bit more memory efficient because he's a vector, I think. But it's not nearly as clean, it's hard to follow. Is he even Ruby? He's not even Ruby. This is like... This might not be Ruby. He may be just tagged as Ruby. I looked this one before. These ones are actually worse because they're all greater than O of N, like O of N to the third. And they're very long. This would be a double for loop. It is not as efficient as mine because it's the brute force method. Let's use permutations. Not completely sure what that is. I'm not sure about this one. I'm not sure what O of N question mark means. This one is O of N. If he did it right. Let's look at his code. This is a until loop. And this is a double loop. Triple loop, actually. And then a fourth loop. So that's not good. that's enough of that. That's pretty much all I want to show you. Thank you very much for watching, and hopefully more videos in the future.